In this section, we'll discuss the schema files, the important ones included with OpenLDAP. Now, they're all important, but some are more important than others. By studying the schema files, we get a sense for the attributes that constitute a schema, which subsequently make an object class, what's required, what's not required, whether or not searches can be performed case sensitively or insensitively, and so on. Let's label this section Schemas. Now, so much of what constitutes an OpenLDAP environment is based on the definition of one or more schemas. So the feature of schemas, or the primary feature provided by schemas, is the definition of fields that constitute an object. So as we've discussed with inet.org person, there are certain fields such as telephone number, department number, and so on. Those are fields that may or may not be required, but nonetheless allow you to define an instance of an object that inherits those particular fields. Now, in OpenLDAP on SUSE and Red Hat Linux, the schema files are located beneath etc OpenLDAP schemas, and in Solaris it's beneath user local etc. So SUSE and RH, we can find these schema files beneath these directories. Let's begin with our master server, Linux CBT SUSE 2. We'll navigate to etc OpenLDAP and LSL. There's a schema subdirectory. That's where you can find the items. But before delving into the schema subdirectory, we should first take a look at slapd.conf, as this is the file that's read by the slapd process, which imports one or more schemas upon invocation. So note etc OpenLDAP slapd.conf is read by slapd process, which imports one or more, it happens to be more than one, schemas from etc OpenLDAP schema upon invocation. When does that take place? Well, very early in invocation of slapd, as is evidenced by the slapd.conf file. The first series of uncommented directives are includes. That's this block that we're highlighting here. These includes include at these particular points in the configuration file the various schema files. So when slapd starts, the first thing it does is it includes the core schema, which is why we'll spend a little time looking at the attributes defined in the core schema. After the inclusion of the core schema, the cosine schema is included. Now, schemas can be dependent, especially the schemas that ship with or come with OpenLDAP, which is why the order matters. Core needs to be loaded before cosine, cosine before inet.org person, because they're dependencies. So cosine is the second schema, followed by inet.org person, and SUSE includes a YAS schema for its operations, for its attributes. So we know that at least these schemas are included. So what exactly exists in the various schema files? Well, we'll begin by looking at core.schema. Now we'll note that it's the first schema file loaded. We'll also note that schema files are dependent, which means the order in which they're loaded matters, which means you should take caution when considering altering the order in which the schema files load. So back to our core schema file. This file, by the way, exists across distributions, regardless of distribution. So keep that in mind. Maybe in a different directory, but nonetheless is there. And before digging in, let's just take a brief look at the schema file on the Solaris side, since we've been somewhat neglecting the Solaris box in favor of SUSE and Red Hat, but nonetheless, user local etc open LDAP schema is the equivalent path. Let's just copy and paste beneath where we've indicated where it's located. And on Solaris, we can expect to find the schema file there. So back to, and let's just enumerate the contents. There we see some of the key files: core, cosine, inet, org person, etc. Back to the master server. So the master server first loads core.schema. Let's take a look at core.schema. And we're not in the schema subdirectory, so we'll prefix it. And now we see the contents, which includes many comments, including comments around what could be defined as attributes, but perhaps are defined later on in the document. Importantly, we'll navigate to the section where comments are no longer, or the uncommented block. And we see the definition of the surname attribute. If you recall, when we created our user, test user, or any of the other users, SN is set to user. This is where, in this core.schema file, the inet org person object, for example, derives, let's just paste this particular user or object into a separate buffer. When an instance of the inet org person is instantiated or created for the user Linux CBT1, the surname attribute is derived directly from the core.schema. So to put it all together, the definition of the surname attribute is derived from core.schema, although the user is defined as being inet org person. It's true that the bulk of the fields that defines the user Linux CBT1 derive from inet org person, but inet org person depends upon core.schema. So some of the fields that we see which constitutes a user object, such as DN, CN, and SN, indeed do not come from inet org person schema, but rather come from core schema. So looking at the core schema, if you want to know a little bit about what constitutes the surname or any of the fields that you can't find in inet org person or in some other schema, look no further than the core schema, which is why the core schema needs to be loaded before the inet org person schema. Because again, if you think of LDAP as a process which instantiates objects based on determined object classes or predefined object classes, which are basically references to schemas, you can't define an attribute which does not exist in your schema. So you cannot define a user of type inet org person unless you have a way of defining one of its set attributes, such as surname. So there's a hierarchy, and this is the OID prefix for this particular block. In this case, surname is .4. They're all 2.5.4, but surname is the fourth defined attribute. So SN, as you see it, is known as SN, lowercase. It's also known as surname. This is an alias, SURNAME. It's described in RFC 2256, and it represents the last or family name. This is the description of it, the last or family name for a given entity. Obviously, this means a human or user-based entity. As we continue through the document, we see serial number, which we have not used, but may be used for other definitions. Country name, again, we have not used this, and it's simply referenced using C. The short name is the way we reference the attribute, but the long name is an optional way. So for example, if we'd like to assign country name to the user Linux CBT1, we can define that object. Let's just show you how it would be done. We could simply indicate C:USA or country name matching its long name. So attributes have short and long names, which we'll document in our notes. And notes, attributes have short and long names for convenience, i.e. C is equal to country name. And we've seen other examples such as CN for common name. CN is equal to common name. Either can be used, and let's say we wanted to again create a user with a country name. Would indicate country name or C colon and the name of the country. There's another attribute which covers one's locality. So wherever your locality is, perhaps your locality or your locale is not a city, a large city such as New York City or San Francisco City. Perhaps it's a small town. The attribute locality name, that is, can be used to store large cities such as New York City or San Francisco City, or small locales. State or province is referenced using ST or the long name. Street, street address. Now notice we're beginning to see some additional items associated with attributes, such as SUP. SUP reflects the top-level object responsible for the given attribute. So in this case, state or province is governed by the attribute name. Let's just note it. SUP name means the higher level attribute, so which means the definition of the higher level attribute SUP, or a name in this case, governs via that SUP reference. And in this case, it is the state attribute. That's what it means when you see a reference SUP, that there is a higher level object, such as a parent object, which governs this lower level object. So SUP name means the higher level or parent object governs this object. Now we should also note, LDAP objects support single inheritance. What that means is an attribute or variable or name value pairs such as ST cannot inherit its attributes from multiple parents. It must inherit its attributes from one parent. Now the inheritance means that any rules associated with a parent object flow down to the child object. So rules inherited from a parent object, and it is always a single parent object unless the specification of LDAP changes. Flow downward to the child object. And that can be anything. It could be rules on syntax, for example, or syntax rules, or what values are permitted for a given attribute. So you may have a numerical field which does not permit alpha characters, and a child object of that particular attribute or field. The child object would not be permitted unless an override is in place to accept alpha characters. Those are just some of the ways the inheritance works. So as we keep going, we see street, fully spelled out, but its full name is really street address. We see that when searching for values that are associated with one's street, that the LDAP search utility is, or the caller using the search function, is to ignore the case and simply match any characters, alpha or numeric or otherwise, presented. So let's just note, let's take the entire block. Equality, case ignore, match, governs whether searches are case sensitive. And in this case, the case is to be ignored. So when you LDAP search the street address attribute for a given object, perhaps a user object, then the LDAP search utility will take any case or match any case for you. And when performing substrings, the substring case will be matched or ignored, that is, when it goes to match. Let's continue. We see organization is represented by O, or organization name. By the way, if you've ever done any work with TLS or SSL generating certificates, whether self-signed or submitted to a certificate authority, a commercial certificate authority, you may have seen some of these fields, such as country, locale or locality, organization, organizational unit. These are all derived from the same sources. The short description of organizational unit is simply OU. We see that in both cases, organization name and OU derive from the name object. So any rules associated with name object flow down. We see yet another field, title. Some other commented fields, and then search guide. Business category, postal address, you name it. So you get the picture here, or you should get the picture that similar to a relational database, an LDAP list of attributes represents the schema that you'd find in a database. A schema in a database is basically a list of files, a list of fields, that is, and the rules associated with those fields. What values are permitted, the limits, so on and so forth. It's the same thing with LDAP. It's just presented to you slightly differently using this syntax attribute type. It has a short name and a long name. The long name can be, or the short name can be considered to be an alias to the field or column or attribute, just like you would using a select statement in a relational database. Select a field name as a more friendly name or as a more useful name, and so on. So this core schema file defines numerous attributes. Here we find telephone number. On searches, telephone number should match. The number supplied to the search should be the number that's matched and then returned. And other not so useful fields like telex number, fax number, which is more and more falling out of fashion, ISDN, which is not as popular, a registered address. As you can see, the framers of LDAP tried to include or provision attributes that match our current world, the way in which we communicate in the world, which is we have physical delivery addresses, email addresses, and other items associated with us. First name, surname, place of employment, role in the organization, etc. So these are some of the fields. We've got fields in here for certificates as well, X509 certificates, password field. These are the fields associated with the core.schema. We're not going to go through each and every one of them. We just wanted to give you a little sense for how it's laid out and how the hierarchy works. It's really straightforward, and you generally do not need to modify or interact with the schema files. If you're doing custom schema work and you're not terribly familiar with LDAP schemas, chances are this is something you'll have the programming or database folks take care of. Generally, the schemas included with LDAP serves most of your needs, most of our needs, but there are times when you need extended schemas, and generally you can get those extended schemas from the vendor of the application that you're using, as they would have done the work to define the attributes and their constraints for you. Now we want to look at another schema file. That's the inet.org person schema file, and we should just note that we have looked at core schema, so the next file is inet.org. It's important because we've been using it, and we use it often to define users, and it will be used when we migrate our user accounts database from etc password to LDAP. So inet.org person.schema. And this particular schema houses, and perhaps we should say represents, because a schema doesn't house anything. Schema is simply a template. It's a database template. It's a list of fields. So it represents common user object fields. Let's take a look at this schema file to see how it is applicable. Less inet.org person.schema, and as you can see from the less output, we've already dumped 19% of it, so it's not terribly long, and given 19%, most of the 19% is commented. The first uncommented field refers to or represents the user's car license. So if a user has, or a user object, an object which represents a user in the directory information tree, if that particular person has a vehicle, a car with a license, then this field can be used to represent that information. Here is one for department number. Now notice, prior to each field or before each field, there's a brief description which explains how the field or attribute works. We use attributes and fields interchangeably because they are interchangeable. Code for department to which a person belongs. This can also be strictly numeric. So it can be alphanumeric. If you belong to, or the user belongs to, a department, department number is the field to use despite its name being number. What this means is, because it supports alpha and numerical characters, we can store the department number as a name, such as sales, marketing, finance, development, engineering, or as a number, such as department 234, or a mixture 2Z4, or sales 15, you name it. The attribute is flexible enough to store a variety of values that represent one's department. We see another one for display name, how the user is to be displayed, especially when you're using a browser tool and a list is returned of inet.org person objects with display names defined. Display name, just so that you don't confuse it with distinguished name, does not use the short name DN. It uses the long name display name. So when using LDAP search, if you've got display name defined, then you'd specify, get me all the values that have display name. And again, for every attribute that we're discussing here, you can use the name verbatim to define values for your objects. So for our template user back here, Linux CBT1, which we should make as test1, and we've already got a test1, but we'll delete it and re-add it. Actually, we've called the user test user1, so we'll delete the user and re-add the user. We can add attributes that come from either of the schemas that we've just discussed. So let's work with display name, and a search against it will be case insensitive, so we don't have to worry about matching it on that front. Display name will be simply test user1. We're making it or setting it equivalent to the common name. And if we wanted to distinguish thoroughly, we could tack on -display such that when we LDAP search, we know we've returned that particular user. Now, because inet.org person depends upon core schema, we will be able to make use of the attribute display name. Here's another one, employee number. We haven't used employee number in any of our definitions. Feel free to do so. This is typically an alphanumeric identifier. So let's go ahead and give this user test user 1 an employee number of 999. And we're already halfway through, a little over halfway through this document, and we see other useful attributes. Employee type, JPEG photo, if there's a path to a photo which represents the user, or a binary reference which represents the binary JPEG dump of the user. Another one is preferred language. SMIME certificate, perhaps for email. Another type of PKC S12 certificate. This is all security related. And a definition of inet.org person itself. When we reference the object class inet.org person, here's its definition. Notice its syntax is a little more complex. It tells us that it is a sub-object, or it is a child of organizational person. It also tells us what may, which means optional, be allowed, and what must be specified. In this case, these fields, which basically covers all of the fields, are optional. Let's just note in our documentation here, may equals optional attribute. Must equals required attribute. Most attributes associated with most schema files are optional. However, that means some, or the remaining, are required. So we see here that the fields are optional. And that's because when you define a user object, you by default inherit attributes from the core schema, some of which are required, such as a CN. If we look at our info here, CN is required. A DN is required, which consists of the CN and the place within the tree. But most of the other items are certainly optional. Now we have this user currently defined. We're at the end of the inet.org person schema. There are other schema files for different purposes, such as one for Java, one for DNS if you'd like to instantiate objects of DNS zones within LDAP. Again, name-value pair. So a given name in a domain and its IP address, version 4 and or 6. So let's confirm our existing environment. Well, LDAP search the most recent instance to find that test user 1. Let's find the most recent instance of LDAP delete. We could of course use LDAP modify, but it might just be as easy to delete the user using a reference to 559, and after being prompted for password and echoing the exit status, we're assured that the object's been deleted, but an LDAP search will confirm. Now let's try to LDAP add. Well, history grep LDAP add. Since we've typed in so many commands, we like to use history to see which one is most suitable, as opposed to rushing to exclamation LDAP add and inadvertently specifying the wrong options. So the most recent invocation of LDAP add is what we want. That's item number 564 in the bash shell. So that'll be, and that's this particular record. 564 will prompt on the command line for us to paste the contents of this new user, which we've just deleted. So the user becomes a new momentarily with, by the way, new fields. Country name, display name, employee, number. Let's paste the contents. Control D. And notice, if a particular attribute is not allowed by the object class that we've imported or assigned to an object, in this case C, it tells you. It tells you it's not allowed for inet.org person. So let's try importing the user without country name. It returns C, which is short for country name. Let's try it without country name and see whether or not it will allow us to do it. And this time it appears to have been successful. So what that tells us is, although the country attribute is defined in core schema and inet.org person depends upon core schema having been loaded, it does not support the instantiation of an inet.org person with the country field or the country attribute, which is not a problem. This is how we learn without digging through the schema files what fields or what attributes go together. So as another task, we or as a task, we imported, created LDAP user based on additional core.schema attributes. And we saw that country name was unacceptable. However, employee number and display name were both acceptable. Now let's LDAP search again. We should see that the user has an employee number and has a display name. And our LDAP search can be updated to search for display name to return records with display name defined, and it returns only one record with display name defined. And we could search the entire DIT. Only one record or one object is defined with display name anywhere throughout the DIT, and that's this particular record of test user. So again, understanding a little bit about the schema is important to your success with LDAP. It's not terribly complicated, but it is also not so straightforward, the fields that are supported for a given object class, which is why you can test the waters by picking fields that make sense from a given schema and then trying to import them. Now, we haven't looked at LDAP browser in a while. Let's reload it. It usually loses its connection when we don't look at it often enough. It times out, in other words. So let's relaunch LDAP browser and re-authenticate. When it pops up, it doesn't save the credentials, so we're connecting to SUSE 2 as cn equals manager, dc equals Linux CBT, dc equals internal, with abc123 as the password. This dumps the tree momentarily. And in OU equals people, we see cn test user 1, and for entry data, we see the fields that are supported. Now, this is a great way, as we've mentioned earlier, to determine the fields supported by inet.org person, or objects that instantiate inet.org person. Here they are: display name, employee number, so on and so forth. You can scroll through this list to see what's supported by inet.org person, even when considering the core schema. So in other words, LDAP browser presents to you only the attributes supported by an inet.org person object. This makes it clear. And also it provides an easy interface to manipulate those objects. So we just define, for example, display name to be such. We can go here and just update it to be a different value. And clicking save causes it to commit to the DIT. And also keep in mind that replication is still up and running using the slowly being deprecated slurpd, but nonetheless our secondary server has been updated, so that means an LDAP search on this server will yield all of the objects, including this test user 1 user. And there you see the latest display name for the user, replicated all within the short time it took us to populate the master server with the latest display name value. So again, it is doing it every 3 seconds, so the values are propagated over very quickly. So again, by no means was this an attempt to write schemas or to heavily debug schemas, but rather it was an attempt to show you how the schemas are loaded, what depends on what, and how to interpret some of the basic important schemas like core and inet.org person.